Today we are learning about exponents. The first thing we need to make sure we understand when it comes to exponents is what they actually mean. So I'm going to take you through working with two different bases, the base of 2 and the base of 3, to help you understand what happens with exponents. So let's start with the number 3. If I have 3 to the first power, that means I have one of my base, 3. So the 3 is called the base, and the 1 is called the exponent. The exponent tells you how many of the base you have multiplied times each other. So I just have 1, 3. Therefore, 3 to the first is just 3. So 3 to the second means I have my base of 3 multiplied this many times. Since my exponent is 2, it's multiplied 2 times. And of course, that equals 9. So 3 to the second means I have 3 times 3, not 3 times 2. So 3 to the second equals 9. 3 to the third then is our base of 3, and how many times do you think we'd multiply it? 3 times, right? Since that's our exponent. So 3 times 3 is 9, 9 times 3 is 27, so 3 to the third power is 27. Now take a second and look at what's happening every time we increase our exponent by 1. What's happening in our pattern here? We have 3, then we have 3 times 3, then we have 3 times 3 times 3. So what we're doing is we're multiplying by an additional base every time our exponent increases. So when we went from 3 to the first to 3 to the second, we multiplied by 3. We multiplied by an additional 3. So 3 times 3 is 9. When we went from 3 squared up to 3 to the third, we multiplied by an additional 3. So we multiplied 9 times 3 to get 27. And that goes on and on and on. So every time our exponent increases by 1, we're multiplying whatever we have by an additional base. So let's look at that example with 2's. So 2 to the first means I have 1 of my base, and my base is 2. So 2 to the first is just 2. 2 to the second means I have 2 of my base, and these are being multiplied together. So I have 2 2's multiplied, and that equals 4. 2 to the third means I have 3 of my base being multiplied together. So therefore I have 3 2's being multiplied together. 2 times 2 is 4. 4 times 2 is 8. So 2 to the third is 8. Now let's see if we recognize the same pattern here that we saw with our 3's. So every time our exponent increased by 1, what should be happening with our base of 2? Every time it increases by 1, we should be multiplying by an additional base of 2. And we see this is the case with our base of 2, just like it was the case with the base of 3. So this pattern works regardless of our base. Now let's go down instead of up. In other words, every time our exponent decreases by 1, see if you can figure out what's happening. So if we were to go from 8 to 4, what are we doing? We are dividing by our base. So 8 divided by 2 is 4. If we decrease our exponent by 1, so we're going down from 2 to 1 now, we're going to be decreasing the 4 to a 2. So again, we're dividing by our base of 2. Now, we're going to use this pattern to figure out what happens when we have a base raised to the 0 power, or when we end up with a base to a negative power. So when I go down to 2 to the 0 power, what should we be doing to this number 2? So 2 to the first is 2. What should we be doing to 2? Well, based on our pattern, we should be dividing by 2. So what is 2 divided by 2? That equals 1, right? So 2 to the 0 power is 1. Now let's see what happens over with our 3's. So with our 3's, 3 to the first is 3. So we're going to decrease our exponent by 1. So we're going from 1 to 0. And so what should we be doing to get from 3 to the first to 3 to the 0? We should be dividing 3 from 3 to the first by 3, and that gives us 1. So every time you decrease your exponent by 1, you're dividing by 3 when 3 is your base, and every time you increase your exponent by 1, you're multiplying by 3 when 3 is your base. So, based on what you see here, what is always going to be any number to the 0 power? What do you think? If you think it's 1, you are correct. That's because any number to the first power is itself. And whenever you go down to 3 to the 0, you have to divide the base by itself, which always gives you 1. So now let's keep going down. Let's continue working with 3 as our base for a little bit. So if we're going to continue to divide by 3, we ended up with 1 when we had 3 to the 0. So 3 to the 0 equals 1. So we're supposed to be dividing by 3 to get 3 to the negative 1. So we have 1 from our previous exponent, 3 to the 0 power, and now we have to divide by 3 again. Well, let's just leave this as a fraction. 1 divided by 3 is just 1/3. So now, let's go down again, another exponent. So we're going to divide by 3 again. So we're going to take the previous number, 1/3, and divide it by 3. Now we know we can't divide a fraction divided by a whole number, so we have to change it to 1/3 times 1/3, multiplied by the reciprocal, which equals 1/9. Now let's take this down one more time. We're going to divide by 3 again as the exponent decreases. So the previous fraction was 1/9. We're going to divide by 3, which we've seen is the same as multiplying by 1/3. So that equals 1/27. Now there are a couple of patterns that emerge here. So I'd like you to take a second and look at what we've done and see if you notice any patterns. So you might want to pause and think for a minute. So did you notice that 3 to the negative first power is the same thing as 3 to the first power flipped upside down? In other words, 3 to the negative first power is the reciprocal of 3 to the positive first power. Does that hold true for 3 to the negative second power and 3 to the second power? Yes, it does. 1/9 is the reciprocal of 9. Does it hold true for 3 to the negative third power and 3 to the positive third power? Yes, it does. 1/27 is the reciprocal of 27. So that's a pattern I'd like you to recognize. In addition to that pattern, I want to make sure that another pattern is very clear. As we are dividing by 3, the same thing, dividing by 3 is the same thing as multiplying times 1/3. We saw that in our examples. We had to change everything from dividing by 3 to multiplying times 1/3 because you can't divide by a whole, or you can't divide by a fraction. You have to multiply by the reciprocal. So I'm going to come down here and write out everything in terms of multiplying times 1/3 instead of dividing by 3. So what we really end up with for 3 to the negative first power is 1 times 1/3, which is 1/3. 3 to the negative second ends up being 1/3 times 1/3, which was 1/9. 3 to the negative third power is 1/3 times 1/3 times 1/3, which is 1/27. So what we're really doing here is multiplying by 1/3 which is the same as dividing by 3, every time our exponent decreases by 1. So when you have negative exponents, what you're doing is you're multiplying by the reciprocal of your base however many times your exponent tells you to. So 3 to the negative third is the reciprocal of 3 one time. 3 to the negative second is the reciprocal of 1/3, the reciprocal of 3, which is 1/3 multiplied twice. 3 to the negative third is the reciprocal of 3, which is 1/3 multiplied 3 times. So let's look at this pattern with 2 as our base and make sure this is clear. So when we get down to moving down 1 with our exponents, we're going to multiply by the reciprocal of our base. So what's the base that we're working with? It's 2, right? So what's the reciprocal of 2? 1/2. In other words, dividing by 2 is the same as multiplying by 1/2. So 2 to the negative first means we have 1 of the reciprocal of our base. So what would that equal? That equals 1/2, right? 2 to the negative second means we have 2 of the reciprocal of our base. So what are we multiplying? We're multiplying 2 1/2. And what does that equal? 1/4. 2 to the negative third means that we have the reciprocal of our base, which is 1/2, multiplied how many times? 3 times. And what does that equal? 2 times 2 is 4, 4 times 2 is 8, so that's 1/8. Again, look back up at our positive exponents and look for the pattern we saw before and see if it holds true. So 2 to the first is 2. Is 2 to the negative first the reciprocal of 2? It is. It's 1/2. 2 to the second is 4th. So is 2 to the negative second the reciprocal of 4? It is. It's 1/4. 2 to the third is 8. Is 2 to the negative third the reciprocal of 8? It is. It's 1/8. These patterns will always hold true. So one thing we've learned is that x to the 0 always equals 1. So any number to the 0 power always equals 1. And we saw that right here for 2 to the 0 and right here for 3 to the 0. And again, that's because anything to the first power equals itself. And then when you divide it by itself to go down 1 or to decrease its exponent by 1, you always end up dividing the number by itself, which gives you 1. So any number to the 0 power always equals 1. The other thing we learned is that any number to the negative exponent, I'm going to write this with numbers for right now. Any number to a negative exponent means the reciprocal of that. So that actually means 1/2 to the positive 4th. And then we could figure that out if we know what the number is. That's actually 1/16 because 2 to the 4th is 16.